All right, these are my video notes in Algebra 2 for a class I'm going to miss. This is section 6.6. It's in the middle of our logarithms and exponential functions chapter. We're actually going to solve equations today. So we've used some properties of exponents last class, the product and quotient and power properties, how to combine them and rearrange and expand logs, and now we're going to use some of those properties and inverse properties to solve for x. On this first page, these are of a similar type. Each one of these has a single expression on, and it happens to be on the left side, but they have a single expression. 1, 2, and 3 each have an exponential expression, and 4, 5, and 6 each have a single logarithmic expression with different bases. So these are going to be a similar style. If you get to solving an equation where there's just a single exponent or a single log, see what it looks like when you change the form. And so what I mean by that is, let's take our base. In this case, it's an exponential. Take your base and let's write it as a log. So this is going to be log base 2 of the other side becomes the argument. So log base 2 of 5 equals the power x minus 1. So I've rewritten the relationship in terms of the log, and now this is a number. It's a little bit more than 2, a bit more than 2, and then so all we have to do to get x by itself is to add 1 to both sides. So x equals log base 2 of 5 plus 1. That would be my exact solution. And then I can grab my calculator and enter. Let's use our change of base. So we'll do the common log of 5 divided by the common log of what used to be the base. This is our change of base formula, and then add that to 1. So that's about, that's my approximation. All right. I'll do 2. Again, we have a base of e, so that's my natural log. So ln stands for the natural log, which is a base with a natural log with a natural base e of 11. The natural log of 11 equals what what used to be my power. So now I'll divide both sides by -2 to get x by itself, and x equals the natural log 11 over -2, or you'll probably see in the book they'll do -1/2 instead of dividing by -2, they'll multiply by -1/2 to make it look something like that. Either way, so that's your exact value, and then here I'll go ahead and get the approximation. The natural log of 11 close parentheses divided by -2, and that would be my answer. So that's my exact and approximate answer there. I can always take that value, that answer, and plug it back up into the original. So the way I do that is I'll do e to the -2. Now I don't want to type this variable, or sorry, this whole long value in. So at the bottom here, above my negative sign, there's in blue it says a and s. That means the previous answer. So I can go second answer, and so that's going to be -2 times, maybe I'll squeeze in a multiplication there, or a parentheses. And it's going to multiply that by my answer. So hopefully I'll get 11. -2 times the answer is the power above e, and it gives me 11. So that worked. That's a good shortcut or a way to check when you have a multiple choice too. So I'll have you try 3. So I'm going to move on to the other set. And then after that, I'll let you do 3 and 6. So same setup, a single logarithm, or similar situation. This time I'm going to change it to an exponent. So the base of 2 to the -1 power equals the argument. So all I need to do now is subtract 5 from each side. So x equals 2 to the -1 minus 5. 2 to the -1 is a half. So it's 1 over +2. So that would equal negative 4.5. Maybe I'll move down to this one. Here, that's a natural log, that's a base e. So write it as an exponent, it's e to the 1/3 power equals 2x. Divide both sides by 2. So e equals half of, all right, x equals half of e to the 1/3 power. That's my exact solution. And I can find my decimal approximation. So why don't you try 3 and 4, you've got one of each, an exponent that you'll need to turn into a log, and a log that you'll need to turn into an exponent. And I will show the answer in the next video.